All right, I promise this is the last video for this section because we're almost done. Anyway, all right, so what did I do? I took a first derivative that tells you increasing, decreasing maxes and mins. I took a second derivative. I got a negative 1/2 sine 1/2 x. I set it equal to 0. I divided both sides by 1/2. So this is going to be where I put my test points, okay? But now I need to figure out where this works. So normally, where does sine equal 0? So those would be x values of 0, pi, 2 pi, 3 pi, 4 pi, whatever. Remember, we're restricted within 2 laps of the unit circle. But that's not what I have. I don't have an x. I have a 1/2 x. So how do I solve for x? I'm going to multiply through by 2. So when I multiply through by 2, 0 times 2 is 0. Pi times 2 is 2 pi. 2 pi times 2 is 4 pi. 3 pi times 2 is 6 pi. And now I'm out of the interval. Okay? So my test points are 0 and 4 pi, which is where my interval starts and ends anyway. And then a 2 pi in the middle. Okay, so now I need to grab my test points. Erase that. All right, so a point in between here. Remember, this negative is important. That's why I didn't divide by a negative 1/2, because it'll flip everything. So here's a pi. Pi is between 0 pi's and 2 pi's. So here's 1 pi. All right, so half of a pi is pi over 2. What is the sign of pi over 2? It is 1. Change the sign, so it's negative. So he is concave down. Okay, 3 pi. Okay, so shove in a 3 pi. That gives you 3 pi over 2. What is the sign of 3 pi over 2? It's negative 1. Change the sign. So now it is positive. So where are you concave down? You are concave down from 0 to 2 pi. You are concave up from 2 pi to 4 pi. And now what is your point of inflection? Your point of inflection is going to occur where you change concavity, which is 2 pi. And then anytime you want to know your y-coordinate, go back up to your original equation. So if I evaluate this at 2 pi, the sine of 2 pi's over 2 is the same thing as the sine of pi. The sine of pi is 0. So that is your point of inflection. And the OCD part of me just freaked out because my stuff doesn't match. All right, so the last few problems I'm going to show you, because what it does is it says use the second derivative test if necessary. But the actual questions are simply, can you please tell me about a max or a min? So what I have here is fine. In fact, I'm not going to do that one. I'm going to do this one. I'll come back to this one. All right. No, that's fine. We'll just do this one. Good heavens. I'm very indecisive. All right. So I've got f of x equals x squared plus 7x minus 8. So f of x equals x squared plus 7x minus 8. And it's asking me, where's your relative max and your relative min? Use the second derivative test where applicable. So I'm going to tell you what it is. But here's the deal. On the way to the second derivative, where do you have to pass? The first derivative, which tells you maxes and mins. So anyway, here we go. I got an f prime of x is going to be a 2x plus 7. Okay? And then my double prime is going to be 2. So what does this tell you? This tells you he is always positive, which means he is concave up. Okay? So if this is positive, that means he's concave up, which means do you have a max or a min? You've got a min because it bottoms out. So that's the point of the second derivative test, is you can figure out if you've got maxes and mins by evaluating there. But in a lot of instances, it's just easier to just stick with the first derivative. So if I do that, my first derivative is a 2x plus 7, okay, equals 0. I need to know if I've got a max or a min. I already know that I have a minimum value. Okay, so I am going to subtract 7 divided by 2. That minimum value, what did I just do? That minimum value occurs at a negative 7/2. And so now I need to know his y-coordinate. Okay, so my max does not exist. Okay, because it's a parabola that opens upwards, so his little arms go up for forever. My relative min is going to occur at a negative 7/2, and then good land to Goshen. All right, so negative 7 halves squared plus 7 times 7 halves, which I know what that is, but I don't care right now. 7 halves, and then minus 8. Math, fraction, gives me 1/15. So this is the location, actually, of your vertex. All right, so let's do another one. We have x to the third minus 6x squared plus 8. And it's asking me for the relative max and min using this second derivative test where applicable. And I would rather just stick with the first derivative test. So I have 3x squared minus 12x. I'm going to set that equal to 0. Okay, so I can divide everything by a 3. So that gives me an x squared minus 4x is 0. Pull out an x minus 4 is 0. So my two critical numbers occur at 0 and at 4. And now I can rapidly tell you if it's increasing or decreasing. Give me a number over here. And remember, I can put it in here or in here. It doesn't matter. So I'm going to grab a negative 10. Negative 10 squared is 100. Plus 40 is positive. So I'm not using the up-down arrows because I'm talking about increasing, decreasing. So just my visual is to use diagonals if it's increasing, decreasing. Between 0 and 4, let's use a 1. So 1 minus 4 is negative. And then 10 gives me positive. So what do you have right here? You got a max. So I've got a max at 0 something. And then what do I have right here? He's a min at 4 something. And anytime you need your y coordinates, you need to go back to your original equation. So 0 minus 0 plus 8 is 8. 4 to the third is going to be 64 minus 6 times 16. And then plus 8 will give me negative 24. So you got a max at 0, 8. You got a min at 4, negative 24. So our last one for this section, yay, is x to the fourth minus 4x to the third plus 1. Again, we can use the second derivative test if we want to, but I'm already here, so I might as well hang out. So I had 12x squared. I'm going to set that equal to 0. Why do I feel like I just did this one? Did I just screw this up? Hang on. Not that you know, because you don't know what the homework says. Anyway, so I'm going to divide everything by 4. As long as it's positive, I can do that. So I get an x to the third minus a 3x squared is 0. Factor out an x squared, so I get x minus 3 is 0. Okay, so I've got critical numbers at 0 and at 3. And I can put my test values either in here or in here or in here. I don't care. I'm going to put them in here just because my brain likes that. So if I go to a negative 10 to the third is a negative 1,000. Minus 300 is going to be negative. Between 0 and 3 is 1. So 1 minus 3 is negative. Okay, so I do not have a max or a min right here because I didn't change direction. Okay, hang on. Yes, that's a negative. And then after that, I get 10, which is going to be 1,000 minus 300 is going to be positive. So you got nothing at 0 because it didn't change direction. But I bet it did change concavity. And then at 3, I'm going to have a minimum value. So my min occurs at 3. 3 to the fourth is 81 minus 4 times, 81 minus 4 times 27 plus 1 gives me negative 26. So you've got a min at a negative 26, I said. But I wrote a second. All right. So negative 26. All right, so that is it for section 3.4.